organizing of your code, and you will think of better ways of writing code, which will save you much more time and energy, and it will be much more fun. So today's session will focus mostly on how to organize your code, how to write it so that you could reuse it, some of the constructs such as if condition and loopings and switch conditions. And there will be some practice. So I highly encourage you to open your RStudio and keep it ready for our session, because we will be learning a lot of new things today. And functions in R is very important. We use it pretty much on a daily basis. And so what are functions? It's A function is basically a piece of code that is executed in one go without interruption. So what is the use of these functions? We are writing code as it is in your console, right? So what is the use of having functions? So a function is a piece of code which could be written and executed even if you have different inputs. It's just a piece of code where you can change the input value given to the function, and it always does one job, or whatever is written in the function. It does perform one activity, and it returns the result from whatever activity or purpose of that function is written for. And it is so the most advantage for it is reusable code. So let me do a full screen mode. And so the major advantage for a function is it is reusable code. So you could use it and it will do the exact same work whenever you use an input. So you could keep changing the inputs, and it will perform the same activity that it's made for. And the other use is because it minimizes errors. And this is one way of having code written that you write a function, you test it with a set of inputs and exhaustive testing, and then that code is good to go because it's well tested. It's tested with inputs. It's written. It's tested. So testing is another part of a daily life of a programmer, because whenever we write something, it's like programmers are mostly lazy, so they write something and then they heavily depend on testing the code because they don't trust um, what they've written. And nobody can really write error-free code. There will be always some errors. So the way we write it is write a line, test it, write a chunk of code and test it if it's working or not. So most likely you'll be missing something, some minor thing, as um, a square bracket or a comma or something. So it's a good way to test a code of function, test a piece of code, square it away in a function, and keep using it and reusing it. So that way, every time you don't have to copy paste a piece of code and change it, and which will likely minimize errors. So if you've not already noticed, from the very first class, we have been using functions as a part of our daily programming. So one of the most heavily used function is this print function. So this print function, we have used it from the beginning. These are some of the pre-written functions or pre-built functions that R ships with. So R has some inbuilt functions already, and print is one of those functions that we have been using. So within a print function, whatever you give it, a string or or a vector or a variable, it's going to print it. So that the job is to print, as the name rightly suggests. And the other two functions, I've not shown you paste, but paste is another very useful function that we use on mostly on a daily basis. Paste is, we will experiment with paste in this session. And round is a function which will round up decimal points, the decimal numbers, to whatever number of digits, how many ever number of digits you want after the decimal point. So let's go into working with some of this code. And we'll start with some of writing some of the code. And here, this example that I have is having a set of numbers and then rounding those numbers and printing the rounded off decimal number. So in this example, you could actually make a script and save it. The purpose of saving a script, I'll show you in a bit why we do this. Mostly in our daily lives, what we do is we write functions in separate scripts and name the script appropriately, and then store it in a place or store it in a directory called, a folder called lib, which is a short form for library, and we store it in there and we source that. So I'll show you. So source, I think we did it. I showed you in the first class, but I'm going to show it to you again here. Usually, in many, the way of calling a function or making sure that the function is in the environment is using the source function. So you write a function, save it in a script. So we are naming it as paste %.r, and we are naming that script, and then we use the source function to call that script. We call that script. What happens is it runs that particular script, and if it is a function, it holds that function in the environment for you until you use it and call it later on. So this is not the way to call a function. I'll show you in a bit how to call a function, but what we are trying to do here is establishing just a piece of code, and then in the next few slides we'll move on to how to make this code a function. This is not really a function right now, but it will become a function later on. I'll show you how to do that. So right, in your RStudio, just try to try to create a vector with some decimal numbers and try this function, which is round of x, and just you could just stop it there. Just write 2 lines of code and you could stop there, and you could just print whatever that is. So I'm going to do it in my R script here. I'm just going to open an R script, save it as paste %. And then I'm going to create my vector here. So you could do the same in your RStudio. I'm just going to create a vector with some decimal numbers. Usually try more than 3 numbers after the decimal, because we are going to try rounding off these numbers. So what I have in the examples on the slide is I am first creating a % and then a round. So what I will do is create a % first. So I'm going to multiply my x with 100 and then round it. And I could paste this into or just print the percent. So this is what I have in my R script. You could directly, for testing purposes, you could directly run it here and check. So just clear it up and rerun it. So X is created, and then I am multiplying X by 100, and then I am rounding it off. So when you round it off and you don't specify how many digits you need, it's going to round it off to the nearest tens. So if you want to specify, there is a digits parameter to this, and if you specify 1 there, it's going to keep one number after the decimal. So let's rerun this. So that's what you get. If you look at the percent, you get one number, it keeps one number after the decimal. So, and it's going to round it off. So this is our set of code, and I have this name for it. And so this is another important thing that you should check while using source. So the other way of running any file or any script, R script, is using the source function. You could just source the R script, and then that piece of code will run for you. So another thing, while if you just type source and give the R script name, so here it didn't run for me. It says no such file or directory. So there is something called a working directory, or the path where my current R is running from. So to check that, there is a function called getWD, which stands for get the working directory. So right now, my working directory is in documents, and my script is saved somewhere else. My script is having a different path. So whenever you run a piece of code, you should always make sure that your R and your script are having the same path. So I'm going to set my path to where my script is, and then I'm going to run my source function, and then the function will run for me. So, and the other thing that you have to remember is in R, it creates a problem with just using one backslash for the path of the directory. So instead of one, you have to change it to two slashes to make sure you are escaping that, because a backslash and then an alphabet means something else in R, and so you have to make sure that that backslash is being converted to two backslashes. Then it will work. So these are two important things that you should remember: to always check the working directory by using this getWD function. So you will see whether your script and your R environment is running in the same place or not. Most likely it will not. So therefore you should set your working directory to whatever the path your R script is stored in. So if not, you could do another thing. Just use this script, use this setwd within the program. So then you could actually run it. But it doesn't mean it's going to change the directory for you. The way we do it is, if we include that over here, we open the script and then run line by line, and therefore we could change it. So the other way you could source a script is to actually specify the path when you are giving the script. So you could take the path and paste it within the source. So that way This way, you're essentially making sure that the source function knows exactly where your script is, paste%.r. So now it's going to run. So this is something I think a beginner, this is one of the beginner's mistakes. I committed this mistake several times when I was a beginner. So this is one. The path is one thing that you have to make sure before using anything like source or for that matter, just calling the script. So so one way is to just specify the path, the full path of the script, or you could use the setwd command within the console. Any questions so far? Okay. So guys, if you have any questions, just unmute your speakers and ask, because that way it's going to make the session interesting for everyone, and there will be engagement. So if you have any questions, just unmute and ask. So I have a question here. It says, is it necessary to have print function to use source? No, it is not. So source function actually means you could run any script. So it right now I'm running paste%.r, but you could run any script. And I'll come to the purpose of using this and bringing this up at this point in just in the next slide, because we actually source, if there is a function, we source those functions before running any scripts. In our scripts, we source some functions, and that is the purpose of source, or you could source or run any scripts. All right, so let's get into our example. Someone has their audio unmuted, so if you could just mute it back. Okay. So this slide, that's what it talks about. We did this. So if you haven't done this, just take a moment to write down at least the top 2 lines of this, and you could print percent. So we could actually, in the example here, I am showing you the use of another function called paste. So this paste, it just means what it says. So you could use any variables and you could use it with some strings. And this paste function has a parameter called separator, SEP, which stands for separator. So here I want my separator as one space. So what it means is whatever you give the parameters you give it, print that with including a space. So this separator can be anything. If you want it to separate it with commas, you can do it, or any symbol you can do it. So because just to show you the use of paste command, I put it here. So I'm just going to include it in my script here, call result paste, and use my percent, which is over here. I'm using that variable, and then I'm going to use a percent symbol just to print the percent symbol. And then I'm going to use the argument sep, which stands for separator, and I'm going to give it a space. So there will be a default for the separator. You can find what the default is by typing the paste in your help over here. All right, so this is what I have, and I'm going to source it once again. So right now it runs and it's giving me this percent symbol right after the number. So what is the use of this script? This script has some fixed numbers. This is what we call as hard coding inside the script, right? So you don't want to write such code because you don't want hard code anything. It should be, your code should be as flexible as to take any changing variables and not be fixated upon the numbers that are written into the code. And we still do it as we still use hard codings at some spots where we cannot really avoid it. But mostly, if you want to write good code, you have to make it variable. You have to make your code flexible so it can take different changing inputs. So here in this example, I have written these. I have created x with these decimal numbers, right? So what if I have a different set of numbers? If say I have like 25 or so every time I have to change these numbers, I have to open the code and change this. What if I have 1,000 lines of code and I have hard coded in multiple places? Every time I have to change those numbers, I have to find where the hard coding is and go and change there. So having fixed numbers is not really very interesting. So that's the use of functions, right? So having a variable input, you should still be able to write a piece of code that will take any number. In our example, take any number, have it converted into a percent and print that percent. So right now I'm going to show you how to change that particular code that we have written to a function. So a function has three parts to it. The first is the name of our function, which is this over here in this example. I named it add percent. And you could name it anything you like, but it would be helpful if it is as descriptive of the function's purpose as possible, because if you start writing multiple functions, then it will be hard for you to remember. If you name it, say, temp or x or anything like that, if it's going to be hard for you to remember what that function actually does. So having as elaborate descriptive names as possible is going to make your life easier as a programmer. So I have add percent, and the next important part of a function is having this keyword function. So the keyword function, and then immediately following that keyword, what you have is the input that function takes. And then you have this flower brackets within which you're going to paste your code. So how will we change our function over here? I'm just going to take off the set directory. How are we going to change here? So what I'm going to do is, I don't want to put this x hard-coded anymore. So I'm going to delete that. And I am going to put the add percent variable. So what I'm essentially doing here is creating a variable and putting a function into that variable. So the keyword function with the variable input, and then start my curly braces and end it right after the piece of code that I want to put within the function. So make it as visually readable as possible. So whenever you have functions, just have it indented with whatever code that goes within the function, just have it indented, maybe add a few spaces to the start of each line so that you know that that block of code belongs to this function. So in RStudio, it's pretty helpful that whenever you type in keywords, it's going to change the color. So this is a function, and you have this little arrow over here. When we use multiple functions within And if I have like 100 lines of code or 500 lines of code, I'm just going to click this one. What it's going to do is it's going to put all the code in a symbol like this. If I click on that, then it will expand. So it's pretty easy way to keep track of how many functions you have. Say if I have 100 functions, then I don't have to step through each code to look at my functions. I could just expand it whenever I need and collapse it now. So I'm going to save this, and what happens if I run this right now? So it's going to run over here, but it's not going to print anything. Right now, what happens is we have added add percent function into the environment. So if you look at your environment over here, you will see that within the functions, this is something that I created, but this is the function that we are looking at, an add percent that is created just now. So we're going to our next slide. So that's what I'm explaining here, just the different parts and pieces of how to create a function. Now, how to use this function? We'll get to that in a minute, but if you created multiple functions, how to look at what is there? You can either look at your environment over here or use something as ls, which is going to list all that you have in your environment. So in my environment, I have all these variables. So remember, add percent is actually created as a variable. It's a function, and a function is assigned to that variable. So it's going to list your function over here, and that's what I have here. And as I just told you, your environment will always have which functions are created under the functions subtab. All right. So what if you have multiple arguments in our function that we just created? Sorry. In our function that we just created, we have just x as the argument, right? So we have x. What if we have multiple, more than one argument? We can so one function we could try using a sum of two numbers. So that's what we could just call it sum of two, because we want a descriptive name. Write another function, and we want to create a sum of two numbers. So let's give the variable names as x and y. You could name it anything, but whatever you give here should be used within your code. So what I'm going to do here is I'm going to write sum as x plus y. And then functions, within the function, you could actually use a function called return. What return is going to do is, once this function is run, it's going to print or return to whatever function is calling it, the whatever variable you give within the return. So here within the return, I'm going to use sum. And I'll just show you how to use this function. I'm going to run this, and nothing happens. It's just going to run it and put it in the environment. So how do I call this function? I could use the function name, and remember, I have to pass it two numbers, right? Two numbers or two anything. But since the function is actually doing an addition of the two numbers, it has to be numbers. If you pass it any other things like character or strings, it's going to give an error. So I'm going to give it 1, 2, and it's going to print whatever is the sum of the two numbers. So this way, it is quite easy to use functions and to make use of it, to reuse functions, just to use one particular piece of code that does one job. So I think you have got the idea of it over here, right? You could try just this function, sum of two, and type in the two variables that it needs to take, x and y. And so these are the two variables that keep changing whenever you call it. So you could use, I used 1 and 2 here, you could use any two numbers, it's going to do the same thing. So any questions so far? I would highly encourage you to take a minute and try just this one function, create this function and run it so that it gets in your environment, and then call the function by using the function name and passing it two variables. It's just like the print function. You write print, you open the round brackets, give something within the round brackets, right? So this is exactly that type of inbuilt function, the similar type, where you give it a function name and you pass it two variables and it's going to return whatever that function actually does. So I'm going to ask you to at least write one piece of code, just the sum of two functions, sum of two numbers in your RStudio, and run it. And just let me know once you have done that. Did you try? Just writing that one piece of code, which is sum of two numbers. Okay, wonderful. All right, so let's go into our next part. Okay, good. So I have a few other examples over here, and you can try it once I give you the slides after the session. Just having like a multiplier to the x instead of just 100, and multiplying those two and passing it whatever multiplier. So another thing that I forgot to tell you is you could assign a default value to these arguments within the function. Say, when I'm writing this function, I want to say, if nothing is given, make x1 and y1. Unless I override this x and y, unless I provide an x and y, it's going to consider it as default values, which are ones. So suppose if I do this, and I just call this function without providing it any arguments, it's going to take the default values 1 and 1. And what if I just change one of the value and just pass it one of the value? So it's going to consider that first value as x, and y is going to be the same default value as 1. And so it's going to add 2 plus y is 1. So it's going to add that. So you could provide it default values just as a safe side. You don't, if you don't want to run, if you don't want people to misuse a function, you could provide it default values. So if I didn't provide default values and somebody runs just with one value, it's going to give an error saying you didn't provide the second value, argument y is missing with no default. So it's a safe method just to provide the default values, and maybe within the function you could have a print statement saying the default values are being used, so that people are aware that there is a default value and they can override it. All right. So let's get into our next part of our session. So until now, we just looked at functions, how to square away a piece of code, test it, use it as a function, right? And within coding, you would want to do much more than just write a function. You will have conditions to test, you will have choices to make, you will have to take actions depending on some values. So therefore, you will have to use some sort of checking mechanism, or a condition checking mechanism, or maybe a looping mechanism where you have to repeat a code for each one of the values in a vector, something like that. So we'll just look at some of those constructs today. So the first of them is an if statement. This is a very simple statement. If you had any other programming class, maybe C um, in your bachelor's, or so if you had C or any other programming language, you would be quite familiar with this construct. It's not new to our programming. It's pretty much widespread in most programming languages. You have an if statement. So what an if statement has is the keyword if, and there is a logical value right after the if statement. There is a condition that needs to be checked, and you have a condition, and you have a condition, and then you have within braces a block of code that executes if that condition is satisfied, if that condition is true. So let's just look at one example. So here I have a function which is called price calculator that we will write now, and that calculates the price of what you charge a customer based on the hours of work you did. So this is the first if statement example. So what we are doing in this example is writing up a function called price calculator, and we use the variable as it is, use the function keyword, and pass it two parameters. One is the hours, and the other is price per hour, PPH. And I'm giving it a default value 40, maybe $40 an hour, right? So 40 and 40 is the default. If you have to change this, you can change it while calling this function, right? Otherwise, if you don't provide the second argument, the first argument is going to be considered as a number of hours, and it's going to take the default value 40. So now it's within the function, I'm calculating a price called net price, and I'm multiplying the hours times the rate, and I'm going to round it off, round it the next net dot price. So remember one thing, I just showed you in the previous example that we use this keyword called return function, just to return some value out of this function whenever you call this function. But in R, if you don't give it the return, this return statement is not needed. And if you just type sum here instead of return, it's still going to return whatever the last value that was printed in this function. So similarly, in this function, I did not give it any return. I'm just going to print this value, right? So similarly, whatever the last value you give it within the function code, it's going to return that value. So the return is not really needed if you type a value within the code. So even here, I'm just going to round it, and I'm giving it the variable name. So that's why it's going to return this value. So until now in this example, we still didn't check for any condition. But what we could do is, suppose if you want to give a 10% discount for some of your largest paying customers, or whoever is giving you more than 100 hours of work, you want to give a 10% discount. So that is a condition, right? So the condition is, if the number of hours of work that you're doing is greater than 100 hours, then you want to give a discount or set the price will be lower, right? So in this example, what I'm using this if statement, sorry, I'm using this if statement to check that condition. So as our previous function states, price calculator is a function that takes hours and price per hour um, price per hour values for this for calling this function, and we are calculating the price as a product of the number of hours times the rate. And now we have to check the condition. So if you check the condition, if hours is greater than 100 hours, then the net price is going to change. The net price will be net price times 9.9. Therefore, which means you're basically giving a 10% discount. And whatever the result is that you want to return, you could type it in this last statement right before you close the function. So when you source this, you have to source it in order for the function to be in the environment, right? Or you could just select this and run it so it is in the environment. So two ways, as I told you in the beginning of the class, you could use the source and call that particular script where your function is, or you could just select this and run it. We select it and run it. So that's pretty much what we do. But if you have like multiple functions written in multiple scripts, then it's harder for you to open each and every script and run it. So you have these commands where you could just say source and that particular script, and you have 10 such commands to call the various functions hiding in various files. So what I'm doing here is I'm calling the function right now. Since I sourced it, it's going to stay in my environment, and I'm going to call the function and give it hours equal to 55. So hours equal to 55, what's going to happen? It's going to come inside this function. Hours is 55. It's going to calculate the net price, keep the PPH as 40. It's going to calculate the next price. And next, it's going to check for this condition. Is hours greater than 100? So hours is 55. It's not greater than 100. So it's going to skip whatever code is written within the braces after the condition. It's going to skip this part, go directly to this part. And you could try this example after in your own time. And when you give it something greater than 100, it's going to go inside this code and execute this piece of code within the brackets after the if statement. So the next construct which we have again pretty widespread in most programming languages, if-else statements. So if-else statement is it means what it says. So if statement, what we are doing is we are just checking for a condition. If that is true, then a piece of code is executing. But in if-else statement, what we do is we are giving it a piece of code to execute when the condition is false. So suppose we'll go back to this example. Suppose in this same example, this piece of code net price times 0.9 will execute only if this condition is true. But what happens if the condition is false? It will just skip this piece of code and then go to this piece of code, right? So what happens if you wanna do something else? If this condition is not satisfied, then comes the if-else statement or this construct. So one such example for this is going to be if you want to determine how much tax to charge a company based on whether you're working for a public sector company or a private sector company. So one such example is this. So this is again multiple arguments that you're passing into the function. We have 3 arguments here for this function. We have the hour and PPH as before, and we added a new argument called public equals true. So we are giving it a default value true, which means if nothing is specified, then it's considered to be a public company. But if it is a private company, you'll have to change this value. And so inside this, we are using the if-else construct. So what we are doing is if public, right? So if just the word public is going to be a condition, because the value of this is a logical value. So whatever, if the condition tests should give it a logical outcome, whether it's true or false, right? So since we have assigned public to a default value of true, we are going to use the true, and it's going to satisfy this condition, then come into this code and execute whatever is after the if statement. If this condition is false, if public was set to false, then it will skip this code and go to the else part, execute this particular piece. So similarly, there are examples here that you want to try, and there are different parameters. Again, arguments are going to be true, and change the arguments and try it, and change the default value and try it. So any questions so far? So, so until now, I think people who have had a programming background, they might be familiar with these constructs. So, nothing really new to or specific to our programming. So there is a shorthand for writing these if-else statements. You really don't need those braces if all that you are going to display is one value. So this is one such example here. I am using this construct to this if-else construct to pick a value from pick one value out of the two values here, 1.06 and 1.12, and whatever the value is, multiply that value with a variable called net price and give a total price. So I'm doing two things here. I am creating a value out of this construct and multiplying that with an already pre-existing value. So this is something shorthand. So you could either, create a variable out of whatever the result of this is, and then use that variable to multiply it with this variable. You can use that, or you could directly write it over here. And if you don't have more than one statement, if you just have one value, you don't even need the braces. So you could try that on your own. So one question people may have is, and which is also important to do, is what if I have a vector instead of, say, one variable or one value? So suppose in this case, what if I have the number of hours, not just one value, but I have a string of values, so I have a lot of values or a vector of values. Say I have 25 hours, 50 hours, a string of values, more than one. What if I have a vector over here? Would this function works? R performs all vectorized operations, right? So it should work. But functions are an exception to vectorized operations. Functions do not support a vector mathematics. And to make it work for a vector mathematics, we have to do a little more than what we have done so far. So to use vectorized operations within a function, we have to use this function, which is called if-else. So this is different from the previous one, because in the previous one, we did use if, check a condition, open the brackets, write a piece of code, then write else, and open the brackets, open the braces, write a piece of code, right? But this is a contiguous function. You have to write it without a space in between. If else is a function that uses vectorized, it works on vectors, and it can perform such functions as the previous one, which is the price calculator, on vectors. So again, every function like the previous one, the if function and if else function, there are three arguments that go into it. There is a test vector with logical values, which is the first argument that goes into this if else function. And the second, whatever you give after the comma within this if else function is going to be the vector if the test vector, whatever the test condition, if that is true, the second one will be printed. If that is false, the third one will be printed. So let's go to one example which will make it clear. So in this example, what I have is I'm using the function if else and I'm passing it a vector with the numbers 1 and 3, and I gave it a condition to test whether this vector is lesser than 2.5. And so 1 is lesser than 2.5, but 3 is not lesser than 2.5. So what it's going to do in this case is the 1 is lesser than 2.5 is true, right? So it's going to go to the second argument. This is the argument that it needs to print when the condition is true. But there is no one value. There is a sequence here, 1 and 2. So it's going to pick one value from this. It's going to pick 1 over here, because we are checking for a vector with 2 values. So the result, even the results, if it is true or false, we have to give it 2 values. So we gave 1 and 2 here, 3 and 4 here. So coming to the second one, 3 is lesser than 2.5. That is false, right? So it's going to go to this third argument, which should be printed when this condition fails. It comes here and it's going to print the second value because we are testing the second value, 3. So it's going to print 3. It's going to print 4. I'm sorry. So any questions so far? Any doubts on this slide? So everybody is with me? I don't see any activity on the chat window. Okay, good. So you could run it with vectors. So here is one thing that I tried that I showed you shorthand for if, like those statements where you could give it as a variable and the output of this is going to be used within this mathematical operation. So I have several other examples which you can try. This builds upon the previous example, price calculator example. All right, so this is another example where we create a data frame of. So in our previous class, we did learn about data frames, and data frames can have different types of data types within the data structure, right? So in this data frame that we are creating, we are having a column called hours and another column called public. And we have a logical vector for public and we have a numerical vector for hours. So this is an example that combines the previous session concept, which is the data frame, and use it with the functions. So you can use that data frame and use this function. So to call a function on a data frame, it's different for calling a function on data frames, and it's different for calling a function on vectors. So for calling a function on data frames, we have to use this keyword, another function called width. You use the width and you use the data frame, and then you give it the function that you need to call. So within the function, since whatever data frame you have, the columns are hours, right? So the columns are hours and public. So what you're going to do is give those column names within the price calculator function. So you pass it the column names for this data frame, you pass it hours, and then you pass in the other column name, which is public. Even if you don't have public equal to public here, it's No, it wouldn't take, because the second argument, if you remember, for this function, the second argument is pph, right? So what if you name it, if you give it just public over here, it's not going to consider it as a third argument. It's going to take it as a pph equals public. So you have to explicitly name as public equals public, or it's going to look for the second pph value. So just try this. This is something which we frequently use because most of our practical use of data will be either in a data frame format, or a matrix format, or something like that. So you could try it here, and this is something that you use if you use if you need like a chain of if else statements. So if there is a chain that you need to use, that means you have a if statement, a condition, you have a piece of code that runs, and then within the else statement you have another set of if else. So you will encounter such that choices that you have to make in your programming, that if not one condition, then another condition, and then even within that another condition, you have two more conditions. So you will have this nested format of conditions that you will need to test in practical programming. So we'll stop our session over here, and in the next class we'll look at more constructs for looping and other conditions. So I hope everybody did enjoy this session, because it's new and it's different from what we have learned previously. So any questions you have for today's session? Any questions? You can unmute your microphone and ask, or type in the chat box. Any question for today's? So the only good thing and important thing that we learned today is the functions. And if previously you had a programming background, or you remember any part of C from your bachelor's, you might have found the if else and if constructs easier. So any other questions? So if nothing else, we will meet back on Thursday, and I will send you the invite tomorrow. And right after the session, right after we close, I will send you these slides, so you have some practice to do before the next session, just to get your hands on the functions part. I think if else, most of our participants will work with it. I don't think they will have problems with the if and if else statements, but I think the more practice you will need is with the functions, because that is something which we use to organize code on a daily basis. All right, so if nothing else, we will sign off and see you in Thursday's class. Thank you, everyone, and good night.